Talk to me about what some of the strategies that you guys use to come up with the equations of the lines. Very good. Right, so we're going to figure out the slope. Very good. So that will be m, and then to figure out the y-intercept, what do you have to do? Where it intercepts y. Very good. So right over run, you already have the 2 points, which is really good. If they're already there, you don't have to worry about that. So I'm just going to do rise over run. I'm going to go ahead and do that so that I don't have to. There you go. I did it for all of them. Let's go ahead and do AB. The rise would be 1, 2, 3, and 4 over 1, 2, 3, 4, 5, and 6, which is 2/3. Jimmy, good boy or bad boy? Bad boy, so that would be negative 2/3. That's where it touches y. What number would that be? 0. That's at 0. That's 1. Very good. So your slope is negative 2/3, and your y-intercept would be b. So the equation of the line for AB is negative 2/3 x plus 1. Okay, at this point, everybody should know how to do this. All right. I'm going to go to CD as well. We already have AB. All right, right. 1, 2, 3, and 4. 1, 2, 3, 4, 5, and 6. So that would be. Now, did I really needed to do that all over again? No, because they're what? They're parallel. So I could just use what I used from the other one. Very good. And I really didn't need to do all this. And because they're parallel, it's still negative. The only thing that I needed to look for in here was my y-intercept. Remember, they have different y-intercepts, the same slope but different y-intercepts. Okay, so the equation is still the same slope. So negative 2/3 x, but then my y-intercept would be what? Negative 2, so minus 2. All right, so same slope, parallel lines. You should know that by now as well, okay? Let's get to the next one. We're going to do EF. All right, so 1, 2, 3, and 4. That's my rise. My run would be 1, 2, 3, 4, 5, and 6. Simplify it again, and that would be 2/3. Okay, Jimmy walking up or down? Has he been a good boy or a bad boy? He's been a good boy, so that would be plus. Very good. And then on that line, check where it hits the y. That's plus 1. It's just like A, right? Just like AB. So the equation for this one would be y equals. Actually, it's not like that one because it's the other one was a negative slope, right? Plus 1. Yay? Yeah. All right, let's do the last one. I'm going to do it in different colors so we don't get confused. Let's do the rise over the run. So it's this guy right here. Okay, so that'll be 1, 2, 3, 4, 5, and 6 over 1, 2, 3, and 4. Let's simplify that. That would be 3/2. Good boy or bad boy? Bad boy, so that would be negative 3/2, right? And then go where it hits the y-intercept, negative 2. Very good. So the equation is negative 3/2 x. Uh-oh. I'm having difficulty today. What's up with this? This is 3, right? Let me write it again because I really want to take a look at this. Okay, what was the equation for EF?
Y equals 2/3 x plus 1.
And then tell me the other one.
Oh,
I don't know. What is wrong with me? I don't know what the heck I'm doing. I broke it.
I don't know what to do.
Okay, wait, let me stop. Okay, so tell me the equation.
For EF,
Okay, so for EF, it would be
y equals
2/3 x,
plus 1.
and then the other one that I did it on blue was y
Y equals negative 3 over x plus negative 2.
minus 2. Okay.
Okay.
So look at the slopes. What do you notice about the slopes? I'm going to highlight them so that you know what I'm talking about. These two?
No.
Now, these ones were the same, right? Because the lines are parallel, right?
Yes.
But these ones are what? They're opposite. Not only are they opposite in sign, because one is positive and the other one is negative. So what is that called when you flip the fraction? Starts with an R. Thank you. Awesome. So these two lines, which is what we're going to be doing tomorrow, are perpendicular. Okay? So parallel lines always have the same slope. Perpendicular lines always have the opposite reciprocal. So you take that fraction, you flip it, and if it was positive, it becomes negative, and if it was negative, it becomes positive. So that's what we're going to be doing for the next 2 days after today. Okay? All right, so let's go to today's work. Good job. That does not, okay? So the first thing that we're going to do is we're going to go ahead and real quick find out if it's a proportional relationship or it's a non-proportional relationship. You should have done this last year in 7th grade, okay? So it should be like a little review. And if you don't remember, I'll probably do a few and you'll be good. Well, yeah, in the classroom that you were, yes, because of the craziness that was going on. All right. Yeah. Yeah, no, don't say that. All right. So get your calculator and let's go ahead and divide. All you have to do to find out if the function is proportional or not, you're going to say y divided by x. Okay? So I'm going to write it and then I'm going to write the answer. That's not what you're doing. So in here it would be 2 divided by 1. 1, which is 2. 2. And the other one, it would be 4 divided by 2, which is 2. 6 divided by 3, which is 3. Oh, I got 2. And I put 3. I know. And I had my coffee. 10 divided by 5, which equals 2. Okay, so what do you notice about the proportional? The y divided by x. What is y divided by x? That's my slope. That's my slope. Okay, very good. Y divided by x is my slope. So they're all the same, right? Yeah. So would you say that this is a constant rate of change? Yeah. Every time it changes, how much? 2. 2. There you go. Okay, let's do the next one. 1 divided by 1? 1. But what is 3 divided by 2? 1.5, 1.5, right? And what is 5 divided by 3? 1.6? And what is 7 divided by 4? 4. 1.7? Okay. And all you need to do is just, divide it and we're good to go, okay? All right. So what's the rate of change over here? 2. It's 2. But what about over there? What would you do if I asked you to figure out the slope of this guy right here? What would you do? If you have a table, where should you go to figure out the slope? Where? Stacks. Not graph. Stacks. Okay, so go over there and tell me what it is. go to start, do the line regression, right? Every time you have a table, you don't even think about it. What is it?
Y equals 2x minus 1.
Okay, so it got the same thing. What about this one? Can you come up with the equation of the line for that one? For the other one? Go for it. I know it should be 2x, right? Because I know that the constant rate of change is 2.
Oh my God. You might be right. Do it and see if you can figure it out. I'll teach you. But double check this to make sure. I think it is.
2x. All right. Plus, now do I really need to say plus 0? No, I really don't. Okay, so now you can always go to stat and do your thing, right? Because I'll show you how to use stat and do a linear regression. Now, what do you notice about those two equations? They have the same slope. Now, they have the same slope, even though the constant rate of change is not really 2, right? But they do have the same slope because it's a line of best fit, which is what we're going to be doing next week. So we're kind of like today, we're like visiting a whole bunch of stuff that we're going to be doing in the next 2 weeks, okay? So it's a line of best fit, which means these are my points, right? And I'm not going to go here, 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 right? Because that looks crazy. So what you do is you make a line that best fits the data. So it's kind of like an estimate, right? So you're estimating the line because you're not going to go from here to here to here to here to here to here. You're not going to go up, down, up, down, up, down. Okay, so that's what the calculator does. Okay, now what other similarities or differences do you see? The constant rate of change will be the same, right?
Yeah.
What else do you see? They're very different. To me, they're very different.
That's -1.
So what does that mean? What's the -1? That's your y-intercept. That means that this line touches the y where? On -1, but this line touches the y where?
0.
Okay, so that has a positive or negative y-intercept. This one always goes through 0. Thank you. This one always goes through 0. So that's another thing that differentiates the proportional from the non-proportional. Okay, so what did you notice about the rate of change for the proportional relationship? It's what? 2, right? M equals 2. What did you notice about the non-proportional relationship? M equals what? 2 as well, so they're the same, right? So what can I say about these two lines? What are they? What type of lines are they?
Parallel.
Thank you. They're not the same. Why are they not the same? They're not the same line. Why are they not the same line?
Can you grab them? Grab them for me. Thank you. They have different y-intercepts. How can they be the same? We could be, you guys are all wearing the same top, but are you wearing the same bottoms? No. Okay? Everybody's wearing the same shirt, right? Because in 8th grade, you're supposed to wear that darn navy blue shirt, right? T-shirt. But are you wearing the same bottoms? No, you're not. So they have the same slope, therefore they're going to be what? Parallel. Thank you so much. But they're not the same line. If this was the mother function, if this was the first one, what did I do to this one? Shifted it how many down? 1. There you go. All right. For which relation does the rate of change the same as the ratio y over x? So for which relation is the rate of change, which is 2, is the same as y divided by x?
The first one.
The proportional one. Very good. So that would be which one?
Proportional.
Proportional one. Okay, so any equation that is proportional is in this shape. It doesn't have a plus or minus y-intercept. It just goes through where? 0. Okay, so it always goes through 0. This is how I can figure out if it's proportional or not. It doesn't have a plus or a minus. And the rate of change is the same. What did you notice about the ratio y over x for the proportional relationship? It's the same, right? Yx is the same as m. That's for the proportional. Okay, what is wrong with my smartphone? Which means it goes through 0, 0. But what did you notice about the non-proportional? Was that equal to m? No, it was not. It was not equal to m. So it is non-proportional. And if you just want to write P for proportional and P for non-proportional, you're welcome to. I really don't care if you know and understand what it means. Now, does it go through 0, 0?
No.
No, it sure doesn't. So there's no 0, 0. Okay? Are we good? Yeah. All right. I need one person to pass out papers. Let's go to the next one. Okay, so let's try that again. Constant of variation would be your m, which is the same thing as k. How do I know that m and k are the same thing?
Because
There you go. It's right beside the x. There you go. There's your slope. The slope is always the one that's with the x. Very good. And it's called the constant. Because you might see it on the test as, find the constant of proportionality, and then you get psyched because you don't know what that means. Okay? So constant of proportionality. That's an R. I'm sorry. All right. If y derives directly as x, x equals 5 when y equals 12. Find x when y equals 30. Don't panic. What did we do for the other one? Y divided by x, didn't we? Okay, so this is what I'd like to do. What are my values of y? 12 and? No, x is 5, right? 12 and 30. And you may want to highlight them in different colors. That helps too. Okay, so you can do the y's in one color and the x's on another one. Uh-oh. That kind of helps me. Because this one is yellow, and then the other one would be green. Okay, so what number goes over here at the bottom? 5. Do we know how to solve this? Jimmy goes fishing. Okay,
can we just divide it?
say that again.
Can we just divide it?
What do you divide?
So we have
You can, but then that's the constant of proportionality. So that would be defined K or M, right? But then how do you figure out this value? You can do that. Let's do it. What's y divided by x? That would be 12 divided by 5. What's 12 divided by 5?
2.4.
2.4 or 2.5?
2.4.
Oh, sure. So this is your M, which is the same thing as your K, right? Now I can go to the equation and plug in the equation. But I'm going to show you an easier way to do this. You can do all this, that's okay. Okay, so I'm going to go to my equation, which is y equals kx, right? What am I looking for? X. That's what I'm looking for. So let's plug in. What's y? 30. I already used the 12 and the 5, right? So 30 equals what's K?
2.5.
2.4. Can we solve that? Heck yeah. You say 30 divided by what? By 2.4, right? Because to solve for x, you divide it. How much? 12.5?
That's where the point, I remember 12.5.
Okay, so 12.5. So what is my equation? That's my x, which is what it was asking me to do. It was asking me to calculate for x, but it was also asking me to figure out the equation. What is the equation? Y equals 2.4x. And there you go. Now, to find the x's is another thing that you can do. You can multiply those two, do that for me, and then divide by the third one. There you go. You've done this in 7th grade. So you can say 30 times 5, which is 150, and then you're going to divide by 12. And I believe you get 12.5. Now that only gives you x. It does not give you the equation. It does not give you the slope or the constant of proportionality. Very good. Or the k. They're all the same. Are we good? All right. Most of the problems that you will see most of them will be like this on the STAR test. There might be a few with word problems, but most of them will be like number 1. Okay? All right, let's do. Heather's weekly pay is directly proportional to the number of hours she worked. So what are the two things that the problem is talking about?
The number of hours you work.
And what?
The
Okay, very good. What depends on what? What should be my x? Hours should be my x, and then my y should be the money, because the more hours that I work, the more money that I get paid, right? Okay, so that tells me what is on my y? Money. What is on my x? Hours. So let's go ahead and figure out. 174 for 24 hours. Get? Because money goes at the top, so that's why. So what's 174 divided by 24? Because that will give me the constant of proportionality, which is the same. How much?
7.25.
$7 and per hour, right? So can somebody give me an equation now?
Y equals 7.25.
That's it. That's all you're doing. Just plugging in that slope, which is y divided by x. Always go, because if you don't work any hours, you're going to get paid. So does that go through 0, 0? Heck yeah. If you don't work any hours, you're not going to pay. You're not getting paid anything. You want some money, you got to work for it. Right, now it says find the amount of pay for 40 hours. So x equals 40, right? Because hours is x. This is why I always like to do this right here. Because then I know what is x and what is y. So that would be, instead of that x, I'm going to plug in y.
40.
25, right? Yeah, 25. Times 40. So how much did she get paid?
$290.
$290? All right, so did I answer my question? Found the amount of pay? Yes. And then I also found my equation. Are we good? Okay, and there are kind of 10 seconds between seeing lightning and hearing thunder. And then he knew that Tulani was about 2 miles away. So what is this two, what two things is this problem talking about?
I needed some.
No. Miles and? Read it, seconds. Okay, say that again. Seconds. 10 miles away, 2 miles away, I'm sorry, 10 seconds. So what do you think depends on what? What is my x? What's my independent variable? Would the miles depend on the seconds, or would the seconds depend on the miles? Okay, so 2 miles away, 3 seconds? Or is it because it's 10 seconds, then I know that is 2 miles away? So you have to know which one is dependent and which one is independent. This one is seconds, and because it took longer, then the miles change. Alright, so y divided by x. So y is my miles, right? So how many miles would that be?
2.
2. Before you sit down, you might need to go over there and get your papers, right?
10.
Divided by
10.
10. So what does that mean? Point what? 0.5 or point, will be 1 over 5. 0.2? 0.2? Now this is your constant of proportionality. 0.2, which is your slope. Very good. So what's my equation? 0.2 x. There you go. That's all you're doing. There's no plus or minus anything. Goes through the origin. All right. If it counted 4 seconds, so what would that be? X or Y? No, seconds. So x. So now my x equals 4. How many miles away would it be? Would it be closer or would it be further away? No, 10 seconds. 10 seconds was 2 miles, so 4 seconds is going to be what? It's getting closer. He needs to get his Ziny out of there, right? He might get struck by lightning. Ah, good thing. All right, so that would be 0.2 times 4, which I believe is 0.8 miles away. So less than a mile away. So that many miles away, and that's my equation. Are we good? Well, only the you just got here. It's not that I'm going too fast. All right, number 4. You need to watch that video. Just 30 minutes of my class. All right, let's go to the next one. A person's weekly pay is directly proportional to the number of hours worked. We've already done one of these, right? What is it talking about? The pay and the hours. And remember, the paycheck depends on how many hours you work. The more hours you work, the more you get. All right, so y divided by x. Okay, what's my y? Let's see. Sean's pay is $123 for 20 hours. So 123 for 20 hours. So let's divide. 123 divided by 20. That's my constant of proportionality or my slope.
6.15. 6.15.
$6.15? Because we're talking about money? All right, so what's my equation? There you go. Now, I have my equation, which is one of the things that I need to look for. And then it says find the amount of pay for 31 hours. Now, would that be X or would that be Y? X. So X equals 31. So that would be 615 times 31. There you go. And then you multiply it, and I don't know how much it is. So $190 with 65 cents? No. Somebody said no. 615 times 31. Can you do it? Just double check. It's okay. Are we good with that? All right. So that's my answer, and then this is my equation. We got 2 more. All right. At top speed, the rabbit can cover 7 miles in 20 minutes. So what do you think this is talking about? I'm going to stop because I already know. Miles and minutes. Okay. So what depends on what? It very good. Depend on that. The longer he runs, the more he covers, right? Which means these are my minutes and these are my miles. And then again, the little graph helps me with the y divided by the x so that I can find my constant of proportionality. Okay, so let's see. 7 miles, 12 minutes. So miles would be my y. So that would be 7 divided by what? 0.58. Is that good repeating?
Yeah.
Do we want to just round it to 0.60? Is that okay?
Yeah.
All right, so what's my equation?
Y equals 26x.
26x, very good. Because this is proportional, it goes through 0, 0.
It's not, I will do one intercept this. You don't have to think about it.
All right, now it says, how long will it take the rabbit to cross 220 miles? Now, is that my y or is that my x?
Y.
So y equals 220. There you go. See, if you organize your thinking, and I know it's a lot of steps, but if you do it like this, you will never get it wrong. Okay? So then I'm plugging in, right? So that would be 220 equals 0.6x. Is that cool? And then I divide by 0.6. It's 300 and something minutes, right? Okay, so 300, can I say just 367 minutes? So that we don't need to, how many hours would that be? What do you need to do?
Divide by 60, because the answers might be in hours and not minutes.
I'm gonna tell you something, because I did it on this last week's test, and almost all of you got it wrong. You're not going back and making sure that you're answering your question. This might be an option, but the answer says the question says how many hours? And then this is 8. And you stop. And you forget that you need to do one more step, which is divide by 60. I don't know, how can we fix this? Because you continue to do it.
I've been telling you for more than a month, make sure that you answer the question and you continue to do it. And I even tell you, answer CAP and that's not the right one. It's going to be your, I even tell you that, right? And I'm doing it on purpose and you did it on one of the problems. When you make corrections today, look back. Because all the information it gives you in 1 minute and 1 unit, and then the question says how many days, or how many hours, or how many, okay?
You need to pay attention, because if you got the A or the B, you know how to do the math. You're just forgetting to do that last darn step. And that's that. You did it on the snapshot with that x equals 6, right? You forgot to plug it in the segment. You did it. Okay, a dishwasher uses 65 gallons of water to wash 5 loaves. There you go. You got your x and you got your y. Which one depends on what? The more water, the more loaves you can do, right? So, gallons, and then loads of dishes, right? Because the more, if there's no water, can you make any dishes? Can you clean any dishes? No, you cannot. Okay. So then let's look for our k. Y divided by x. Okay, so 65 gallons would be what? My x or my y? My x. So that goes at the bottom. And then which means 5 goes at the top.
So what's 5 divided by 65? It should be
Okay, one person. 0.0. Okay. We can do 2.08. It's just a lot easier, okay? All right, so what's the equation?
Y equals
0.08 x. Okay, it says, how many gallons of water would be used to wash 12 loaves? Now, loaves is x or y? Y. Which means y equals 12. Yay?
Yes.
All right, now I plug it in, right? So 12 equals 0.08 x. Divide by 0.08. And you got, how many gallons of water do you need? 150 gallons?
150. Yeah.
Is that what I'm hearing?
Yes.
My ears are old, and on top of that, I have this earphones on, so I can't hear. Are we good?
Yes.
Yes? Okay, what time is it? Okay. So this activity you're gonna do in groups, okay? Yeah, at 9:20. 9:10. Yeah, we still have 10 minutes. Take your time. So we'll go ahead and then we'll make corrections. Okay? Who's gonna pass them out? Well, I got my 2 workers already. No, they're the same.